Welcome to the Explainer. Today, we're tearing apart the 8085 microprocessor to see how computer brains actually work.
We'll go macro to micro, from its foundational buses and an internal engine, down to its language and execution timing.
So what is a microprocessor? It's basically a programmable chip that makes all the digital decisions.
To communicate, it uses buses. Think of these like actual superhighways for zooming digital information around.
Address finds the exact location, data carries the actual info, and control, well, it manages the traffic.
Let's look inside the engine. This incredible architecture holds the ALU, which cranks through all the math. You'll also find registers in here. They're basically tiny storage lockers holding data during super quick operations.
Two key pointers here. The program counter queues up the next instruction, and the stack pointer tracks memory.
After doing the math, it checks these 5 flip-flop flags to flag conditions, like a 0 result.
Zooming out, the 8085 literally has a 40-pin nervous system plugging it right into the outside world.
These pins are grouped up, handling the whole shebang, from powering the chip to managing outside interruptions.
But how does it actually think? It runs commands broken down into these 5 functional steps.
This maps out its language perfectly, translating assembly commands right into 1, 2, or 3-byte machine codes.
Time to check its heartbeat. The whole execution process relies on instruction cycles, machine cycles, and T-states.
Look at this timing diagram. Pulling off just a single operation requires multiple, incredibly precise clock pulses.
If this 8085 heartbeat ran at just 3 megahertz, can you even fathom the speed of today's chips?